Hi, I'm Gene Benson, and I would like to welcome you to our Pilot Talk series sponsored by Avemco Insurance. This presentation, along with all the presentations in the series, qualifies current and new Avemco customers for a discount on their insurance premium.
Okay, welcome everybody. Welcome to our Pilot Talk series of webinars. Today's event is titled Engine Health Monitoring, Fly with Confidence. I'm Gene Benson. I'll be your host once again today. In case you didn't know it, Avemco is a sponsor of the FAST team and pays for the wings that we receive when we complete a phase of wings. At the end of this presentation, I'll tell you how you might be eligible for a discount on your aircraft insurance for attending this webinar. So stay tuned. Let's start with a bit of housekeeping here. We always begin live seminars. We're pointing out the exits and the bathrooms. Well, we'll leave it up to you to figure out where those are in your location. Our emergency would be some sort of a crash on our end. That's unlikely, but it's not impossible. So if that was to happen, please check your email and we will reschedule, or check the website vectorsforsafety.com and the reschedule post will be there. But we hope we don't have any problems like that at all. Also on the controls with me is my friend and colleague Lane Lisser. Lane will monitor the questions. Just type questions into the Q&A box and we'll do our best to address them. Those of you who attended the Better Decision Making webinar will remember Lane for sharing his engine failure story with us. If you missed that event, there's a recording available on my YouTube channel, and there's a link to all the previous webinars on vectorsforsafety.com in the Pilot Talk section. And now to introduce our guest presenter today. Shawn Benson is a graduate of Embry-Riddle Aeronautical University with a BS degree in Aviation Maintenance Management. He holds FAA certifications including A&P, IA, and Private Pilot. He's also a FAST team representative. He has more than 25 years experience in the aviation industry, including both airline and general aviation. And yeah, we're related. Shawn's my son. He was slated to do this presentation at AirVenture, but with that being canceled this year, he's doing it as part of our Avemco Pilot Talk series. Before Shawn begins, we want to thank Aircraft Specialties of Tulsa, Oklahoma for the use of their slides in this presentation. Aircraft Specialties Services has been in business for 35 years, and they are proud to be the largest and the most sophisticated engine component machine shop dedicated to the piston overhaul market. They specialize in crankshafts, camshafts, magnaflux, and machining services. All right, with that in mind, just bear with us a second here while we change presenters. And there we go. Shawn, I think you have the controls, and I'm going to go ahead and turn my webcam off. You're on.
All right.
Perfect.
Thank you, Gene. Thank you, Lane, for the invite. Appreciate the opportunity. Today we're going to go over engine monitoring, flying with confidence, how to gain peace of mind that your aircraft engine is healthy so that you have the confidence to fly your aircraft. I'm going to go ahead and turn my camera off. There you go. All right, so let's start through this. There we go. All right. So does flying at night or over the mountains give you a case of the serious heebie-jeebies? If it does, all right, the best way to fix that is to figure out how well your airplane and what your personal skills actually are. So today we're going to talk about the aircraft engine and what you need to watch out for with trends and how to improve your safety margins with your engines. All right, so this presentation is going to take the mystery out of what goes behind engine reliability and to figure out what the precise state of your engine health is. All right. Piston engine wear and reliability are well understood if you know what you look for before you hit the start switch. Right? There's no mysteries with piston engines. The failure modes are well known, and most of the failure modes, if not all of them, have warning signs that if you're doing a proper trend monitoring with your engine, you will know what to do and can fix the engine typically before you get into an overhaul type situation or an engine failure. All right, so what we're going to go through in this presentation is opening thoughts. We're going to do a brief review of typical wear trends in a piston engine, your typical Lycoming and Continentals, the types of engine wear monitoring that are available. Easiest one is to do visual inspections of the engine. All right, proceeding further than that, we're going to go into oil trend analysis, how that works, and kind of take some of the mystery out of that. We'll look at the relevance of cylinder compressions and the advantages of electronic engine monitoring systems. We'll wrap it up with some conclusions, takeaways, and opportunities for questions. All right, a little bit about aircraft specialties so that you kind of get an idea of what their knowledge is in the industry. They've been in business since 1977, right? They are the primary vendor for reconditioning all steel components within the general aviation fleet, primarily Lycomings, Continentals, and Franklins, right? They process at least 3,500 crankshafts per year, 2,500 camshafts, and over 10,000 tappets per year. Right, that level of experience and the high technical expertise that they have gives them a very good insight as to the condition of removed components and what causes those failure modes. All right, so engine wear, right, engine health and reliability are all interrelated. Engines actually wear with both use and inactivity. Inactivity, not flying your engine, right? Not flying your airplane, is actually worse on wear trends than flying the airplane. So if you get nothing else out of this, properly fly your airplane on a regular basis and you'll be in a lot better shape than it's sitting. All sources of engine wear can be tracked and traced, right? And the rate of engine wear can be tracked so that you can know of an impending failure mode before you get to a failure mode. Right. Basically, engine health is the accumulated knowledge of all your available wear indicators. So what's all that mean, right? So let's take a look at what typical wear trends are in a typical aircraft engine. All right, so an aircraft engine is considered a complex component, right? It has a predictable useful life and is achieved by requiring periodic inspections and maintenance, right? So the periodic inspection and maintenance that's involved in the engine, the minimums are going to be mandated by the FAA and the engine manufacturer. And overall, these two charts overlay. The one on the left shows all of the failure modes that are possible. And then the chart on the right is called the bathtub curve, right? And that is basically the average of all the different failure modes. Key thing to remember that engines fresh out of overhaul or any level of heavy maintenance work on them re-put you onto the bathtub curve in the infant mortality region, which is the front of the curve. Right? So take this out over the lifespan of an engine, right? When an engine comes fresh out of overhaul, you have all of the infant mortality or the areas to where something was mismanufactured or it was installed improperly, a torque got forgotten, a seal got forgotten, something like that, and that puts you into an infant mortality mode. All right. Once the engine has roughly 200 hours on it, you're now into this part of the bathtub curve. And at that point, the curve pretty much flattens out. Now what that means is that there are still going to be engine failures, but they're at a consistent rate. As you move along through the curve over time, right, notice that the curve goes back up, which is the end of life wear out with an increasing failure rate. So your established factory TBO numbers are typically right here just before the curve starts to go up. So this is the iconic 2,000 hour TBO number, right? That's where that in lies. So there's numerous different failure modes that are possible in an engine, but they're well known. Most of these can be caught early. Things like exhaust valves, guide wear, some of the other telltale signs of engine work can be predicted via oil analysis, and you can pull a cylinder or replace an individual component and not have to go into a top overhaul or a full overhaul situation. All right, commonly thought of wear areas. All right, cylinders. Cylinders, they've got rings, you got pistons, you've got constant movement, run a couple thousand RPM per minute for hours and upon hours, so everyone expects to have wear in that area. Okay, piston rings. All right, piston rings are the seals basically that are made out of metal that go between the piston and the cylinder, and that's what provides the ability for the engine to have the compression ratio. Those don't necessarily wear nearly as much as they have a tendency to stick, and when they stick or can't rotate anymore due to deposits, they will break. Right? That causes internal engine damage when they break. All right, valves and valve guides. Slow, steady wear is expected on those components. Their failure modes can be predicted through oil analysis and can be pulled before you have a valve problem on a cylinder. Camshafts and tappets, right? Unfortunately, that's the most unpleasant news you're ever going to hear when it comes to your aircraft piston engine. With how these are designed, camshafts cannot be replaced without splitting the case, which means that you are into the territory of requiring an overhaul. Some aircraft engines, the tappets can be replaced. For example, on your larger Continentals, they can be replaced in service. But unfortunately, on the vast majority of your Lycoming fleet, the tappets cannot be changed out. You have to split the case to get them out. So we want to make sure that we protect our camshafts and our tappets as best as we can, because that will minimize overhaul costs. All right, crankshafts. Crankshaft wear is expected, but they really don't wear nearly as much as you might think. Right? In the general aviation fleet in particular, crankshafts typically corrode out before they wear out. And that's really kind of an unfortunate situation when the average cost of a crankshaft is about $7,500. All right. So where does all this wear material go? Right? It actually goes into the oil supply of the engine. Okay. The rate of accumulation of the wear metals is directly proportional to the expected life of the engine. So if we're monitoring consistently what the trace amounts of wear metals are in the engine oil, we can get a very good idea of how much life is remaining on those components. Okay. Many owners and operators take the time and financial commitment to conduct oil analysis, right? But few people truly understand what the significance of the data is. So we'll go through some of that as we go through. Right. Oil analysis program depends on the data trends. Consistency is going to be the key. Oil analysis cannot detect broken parts. So if you have a situation where something breaks internally, it's not wear, it's an actual failure mode. So oil analysis will not detect the actual break in the part, but a normal wear pattern that exists, like for exhaust valve guides, that will be able to be tracked. Give you an example. All right, so here's some pictures of some tappets. All right, tappet and camshaft failures in service are the most common reason for engine overhaul, unfortunately. The two pictures that you see on the right of your screen, the first one is that kind of looks like the face of the moon. That is unfortunately severe corrosion and pitting. And the cause that you see that on that tappet there was actually caused from blow-by from the opposite side cylinder. So all of the combustion gases that were able to escape around the ring on the other side of the engine blew over onto the cam and the camshaft lobe and the tappet and caused accelerated corrosion. Right. Then the stresses imposed by the camshaft tappet interface just spalled it right out. The picture on the lower right is more indicative of inactivity corrosion, and all those little specks that you see there are actual corrosion pits, and that would that eventually will take your camshaft interface and cause accelerated wear, causing an engine overhaul situation long before the anticipated TBO. All right. Interestingly, many operators actually have engines in service with these conditions that you see in these pictures here. The manufacturers have limits for how much corrosion and how much wear can be on those components while in service, but you're not going to get to full TBO if you have any of these situations starting. So the key for this one is manage, if you do have this condition, you manage it so that it doesn't get any worse. And if you've got a new engine or a newer engine that hasn't gotten into this situation yet, you take the necessary precautionary maintenance measures to prevent that from happening, and the bottom end health of your engine will get you far past TBO. Right. Pretty much the non-repairable condition of these components is going to be corrosion. Right. Believe it or not, the picture of the tappet on the lower right can be completely overhauled and refinished and run a full service life. All right, camshaft. All right, camshaft and camshaft failures in service, right, again, are the reason why engine overhauls have to occur. Here's a picture of a camshaft lobe, right, heavily corroded, and because of the corrosion factor and the wear, it had accelerated wear, which reduced the ability of the engine to make power, causing, in this case, I believe the engine overhaul had to occur at 400 hours in service. The camshaft tappet interface is the most stressed component in the engine, right? So this is where proper engine warm-up, proper use of the right oil, using corrosion preventative measures. This is what it's all about right here. Right? Non-repairable conditions, unfortunately, for camshaft are going to be corrosion primarily, and then a damaged lobe, right, or wear that cannot be reground and reprofiled. Right? The vast majority of camshafts in service, unless the cam has been completely ground down in service, can be recertified and run a full overhaul cycle. Connecting rods. Right. Connecting rod failures in service are extremely rare. When you get into a situation where there's a rod type failure, it typically goes back to being a failure mode on installation, improper torquing of the connecting rod bearing interface. There's also a Lycoming AD on some small end bushings, right, to where you have to check and make sure that was a manufacturing defect that were made too small so that they don't expand out into the opening and can migrate and cause problems. So that's what, if you've got an engine that you're dealing with the AD on that, the easiest answer is to pull the cylinder, have the connecting rod rebushed, and terminate the AD. All right. Rods overall are very simple. They're robust and provide an extremely long service life. They're very easy to refurbish, and typically rejections on those type of parts are caused from corrosion, from disuse, shipping damage, right? Folks shipping them in or improperly storing them on a rack and having metal-to-metal contact, taking a chunk out of it. That usually makes them unserviceable. Distortion, some type of another problem that caused the connecting rod to bend, like detonation, right? And then wear on the big end thrust faces, which is the end that connects to the crankshaft. They have to have a certain width because there's an overall tolerance between the crankshaft journal and the width of the connecting rod. And if you can't maintain that distance relationship, then the connecting rod is no longer serviceable. All right, crankshafts. Crankshaft failures in service are actually very rare. Aircraft Specialties routinely refurbishes crankshafts through 4 to 5 overhaul intervals. This is going to be more for your commercial operators. Well over 10,000 hours in service. Typical wear when they're received in is between 5/10,000ths and 1,000th of an inch. Right? Depending on the manufacturer, these engines can be, or crankshafts can be ground down to, you can remove 10,000ths of material, which is 10 times this amount. And in some situations with STCs, you can go to 20,000ths on lower horsepower engines. Right, non-repairable conditions are going to be corrosion, right, and cracks. In the graphic here, got 2 examples here. I'll talk about this one right now. This is a crankshaft that is going under magnaflux, right, or mag particle inspection. This is where you magnetize it and use a special indicator that finds the cracks, and then it basically illuminates it under a dark light. So all these lines that kind of look like scratches here, down here, those are actually cracks. This particular crankshaft had a prop strike, and that's what caused all of these cracks here. All right. More common is going to be corrosion. This is a crankshaft journal here, and those dark lines and spots are actually corrosion pits. And in this case, the pitting is too deep to be able to be remachined and still maintain the distance, the width of the journal. So therefore, this particular crankshaft is a $12,000 crankshaft, and this was the only thing that couldn't have been repaired on it. So customer had to spend a lot of money simply because of corrosion from not flying the airplane. All right, let me stop here for a second. Does anyone have any questions? Lane, do we have any relevant questions?
I'm not seeing any questions yet so far, Shawn.
Okay, well, that's good. Hopefully that's a good break, long enough for everybody to wake back up, so we can go to the next slide. All right, so types of engine wear monitoring. We have visual inspections, oil trend analysis, cylinder compressions, and electronic monitoring. All right, visual inspection areas. All right, easy thing to do. Starts with the pilots on walkarounds. Good external engine pre-flights. All right, look for case condition for what you can see. If you're in the maintenance mode, right, decal it and get a good set of lights on it and look all over it, and make sure that you're looking at the case. Right, look at the cylinders and make sure that you have proper baffling and cowl seals. Baffling is sometimes neglected on airplanes, and it's really important to make sure that you have proper airflow through the cowling, through the nacelle, so that you don't have any localized heating for the engine. That does a lot to prevent cracking in service. All right, the engine internals, all right, sounds kind of basic, but when you check the oil, look at the color of the oil. Right? See if you've got a smell to the oil that's not normal. See if it smells burnt. Okay. We'll get into oil filters, screens, and borescopes a little bit more as we go through the presentation. All right. Here's a good picture of a Continental 6-cylinder engine case. And unfortunately, in the aircraft maintenance world, the red lines are not automatically drawn for us. That's dye penetrant inspection there, and it shows a tremendously large non-repairable crack in the case of the engine. That crack, unfortunately, was caused by improper maintenance when the cylinder was changed. The torque value was not able to be maintained on the case with how the cylinders had been removed. Allowing the case to be too loose between the two case halves, which actually caused the crack. But this is why this is so important. Track down and resolve all your oil leaks. Right? If you have a small crack, you may not be able to visually see it when the engine's sitting cold in the hangar. But when the engine warms up and it runs, that crack actually expands a little bit when the engine is heated. And believe it or not, oil will creep through that and seep. And then when you shut the engine down, there might be a little bit of a weeping oil line, right? That you'll see the oil, but you will not see the crack. So make sure that you look and be very particular about oil leaks, right? We all know that all aircraft engines leak some amount of oil. They're kind of designed that way. It's kind of how they go. But there is a difference to where you need to be looking for oil that's in the abnormal places. These are things to be watching out for, especially with cylinders. Cylinders can actually be cracked, and you'll have a little bit of oil seepage at the end of between the head and the barrel of the cylinder. I've actually seen multiple cylinders at this point that were cracked more than halfway around the circumference of the cylinder. And the only way to have detected it was through the oil leak that was occurring. Compression checks did not catch the crack, and with where they were installed on the engine, NDT procedures would not have caught them either. So kind of watch out for that. Case cracking and crankshaft cracks can be detected if you've got a constant speed propeller. Sometimes crankshaft cracking can actually show up as a starting point where you think it's your prop governor. All right, proper baffling and cowl seals. Make sure that you have proper airflow so that the engine has the best chances for proper temperature control. All right, let's look inside the engine a little bit here. All right, the engine oil. One of the most basic trends that you can do, and it's very low cost, is to track how long it takes for the color of the oil to change from that nice clear yellow down to the opaque brown. What you see here in this graphic here, this represents new oil in service, and then as it progressively gets darker over time in service, when you get into this area here, it's time to change the oil, regardless of the 50 hours or the 25 hours or whatever. You need to be following this for proper engine trend and proper troubleshooting. If you have a typical engine and this color change takes typically 30 to 40 hours, let's say for an example, and that's what your engine's been doing, and then all of a sudden you go from this color brand new oil to this dark nasty looking oil in, let's say, 5 hours, you need to start doing some immediate maintenance and inspections. That is a telltale sign of blow-by past the cylinder rings, which means that you've got a cylinder that is not sealing. Could be something as simple as some FOD or some deposits on the rings, fairly easy to fix. And the situation, if it's not checked out early enough, is that blow-by is going to cause corrosion on your camshaft. So that's why you want to be proactive with monitoring the oil. This is a very quick and easy visual inspection. You should be checking the oil every pre-flight anyways, right? It's also part of knowing your airplane. Okay. Always change the oil when it appears dark or opaque. Right? And always new oil and filter regardless. Okay. General scheme of things, oil is cheap, so are filters. A lot cheaper than an engine, major engine work. All right, oil suction screens. Everybody's got one very much like this in the picture. All right. Oil suction screens are the first line of protection for the oil system. And what we say is it captures the big chunks. Those are the pieces that have got serial numbers written on them. These are the pieces that are going to be way too large for an oil analysis to catch and allows the engine to continue to operate and have a pretty much clean setup with the oil. All right. Unfortunately, no real wear trends can be ascertained by inspecting the screen, but pretty much most anything that you find in this oil suction screen is going to require immediate maintenance action. Right? Light combing says to make sure that you inspect and clean this at every oil change. Continentals have a very similar setup. Unfortunately, with how most of the airframe installations are set up, you cannot actually pull this in service without loosening the engine from the mount. So that's typically done at annual. Okay, oil pressure screens. Some engines still have oil pressure screens rather than the spin-on filters. Remember that this is a mandated 25-hour oil change or less. Typically, the first visual indicators of the presence of wear metals that you can physically see are going to be either in your oil pressure screen if you have one, or it's going to be in your spin-on oil filter meter. Right. Not the best method for trending, because pretty much by the time you see it there, you've got a problem. So it's something that has to be looked at. Big thing with this is that it can indicate a sudden shift in wear patterns. All right. Anything that you find pretty much happening in the screens or in the filter media, oil analysis will have picked up much in the engine service life. Right? Any sudden increase in content necessitates troubleshooting. The manufacturers do allow for a fair amount of metal. The untrained eye would see how much metal is in that filter and see what's allowable. It's scary to the untrained eye, but there are allowable limits for how much metal an engine can make, but you also have to be very careful with that and follow the inspection criteria that the manufacturers lay out. All right. So anytime you change the oil filter, all right, keep the contents of what's coming out of the filter. Wash this out with solvent over a coffee filter, all right? And if there's a fair amount or you have questions, you can send that material to a lab and they can do an analysis of the metal, and based off what those results are can tell you pretty close where it is in the engine, especially if it's a little bit more of an exotic metal or if it has other traces of materials with it. It could be like a nitrided cylinder or something a little bit more specific so that you can identify where the metal is coming from. Keep in mind that the metal may not be bottom end related. It could be something that is easily changed without requiring an overhaul. So don't necessarily initially panic if there's a little bit of metal. All right, key point here is never throw away the data. Always keep the data, keep good records, right? Consistent oil changes, consistent trend monitoring are really important. All right. So the spin-on oil filters, very easy way to establish a low-cost trend monitoring option. Right? So you can establish your trend by either saving the media or photographing the details that you find in the media and then keeping it for reference for the next oil change. It's really much easier from a troubleshooting standpoint because, quite frankly, nobody remembers after a couple days, especially if you're looking at a lot of these filters and whatnot, what it looked like the last time you changed that particular filter. So keep good paperwork, keep some good documentation. It's very low cost to take your filter media once it's inspected, right? Fold it up and put it in a Ziploc baggie and put it on the shelf, right? Bag it and tag it so you know what airplane it came out of and when it came out with the date and the hours, and now you've got an easy way to go and look for trends. All right. Keep in mind that consistent oil changes are kind of key with this. Remember that if your oil filter went 50 hours, it's going to look a lot different than an oil filter that went 25 hours. All right. Again, don't throw away the data. All right, so let's take a look at some of the contaminants that you might see in an oil filter. Some of you may be changing your own engine oil. You may have someone providing the service for you, but these are some kind of an interesting situation of what you might find. All right, so all of these are photos under magnification, of course. What these would look like are small specks in your filter media. The graphic on the left is your lifter tappets. All right, so that is a situation of a lifter is coming apart in the engine and it was picked up in the filter media, and that's kind of what they look like. Just looks like a whole bunch of metal, right? Kind of a interesting thing is under a microscope and with the trained eye, you can find that it's cast, and then using testing methods, you can actually determine the alloy or the type of material, and it'll tell you where it is in the engine, what component. The picture on the right looks like a whole bunch of dirt. Unfortunately, it's not dirt. It is a cylinder bore coming apart due to misalignment, and that is phosphate-laden iron. And the key for that is with it being the phosphate, it's the coating that's on the cylinder wall, and that's how you can identify it. Food for thought. All right, on the left, you've got some bronze bushing material, and when that's checked at a lab level, you can identify that it was from the oil pump gears. Oil pump gears can easily be changed in service without the need for an engine overhaul. So you can get something like that, and relatively easy fix. Keep the airplane on wing. The picture on the right, the brass slivers. If you have a Continental engine with a starter adapter, which most of you would. This is the indicator that you will find in the filter media if you have a starter adapter in pending failure or has actually failed recently. So maybe you have had a starter adapter fail and it was replaced. If the oil change had not occurred with the starter adapter change, it is common to get some of these whiskers in the oil filter media at the next oil change. It's pretty much a common practice, though, if your starter adapter fails, change the oil also. All right, on the left, looks like a whole bunch of trash. That is the remains of an aluminum piston pin plug. That is actually easy to correct within the cylinder. Between oil analysis, oil filter, and a Borescope, you'll be able to identify which cylinder or cylinders are having piston pin plug wear and can easily be corrected without overhaul. All right, and then if you're ever curious, engines fresh out of overhaul, they're typically run for a few hours on a test cell, test stand. If you if you do have an engine overhaul and you elect not to have it run on a test cell and you get it straight, you may run it for the first hour and then open up the filter like you should. This is what you would typically see, would be a little bit of remnants of sealant, debris that didn't get quite cleaned out of all the nooks and crannies in oil passages and whatnot. And that's typically what you don't want to have, but you will always have some level of it. This is a little bit on the excessive amount in that picture. If you're doing engine work out in the field, and you have cylinder work done or any kind of invasive surgery on your engine, cleanliness is extremely important with these engines. So good shop practices are very important. All right. Picture on the left looks awfully similar to some of the other pictures that we've seen. Unfortunately, that's main bearing material, and that tells you that the engine is going to need an overhaul. Picture on the right is more of a copper bronze again, and that is from the Vermatherm. Now the Vermatherm is a little thermostat that is mounted outside the engine that regulates the amount of oil that goes to the oil cooler. Heats up, the warmer the oil is, the more oil is ported towards the oil cooler. When the engine's oil is cooler, the valve is closed, bypassing the oil cooler. Again, that's a couple $100 component. If you have that coming apart and you find debris, very easy to fix. All right, a couple last examples here. Piston pin skirt fractures. Again, some other examples there. The one on the right is going to be the gear for an alternator, and it's got some elastomeric or some rubber attached to it, and that is the indicator for that. Bearing materials. The picture on the right is a good example of a combination of bearing material and crankcase frutting, which is a situation when the crankshaft halves, the through bolts lose torque in service. And the two case halves, through vibration, chafe and wear. Okay. Quick check here, Lane. Any questions?
We have a couple, Shawn. One, Howard Greenberg says, can you repeat how many hours we should be concerned when the oil gets dark quickly?
Okay. What you're looking for is a rapid rate of change. If your engine normally goes from that nice, clean, new oil to the dark, nasty looking oil, it typically should be somewhere in the 30 to 35 hour range. Okay, that would be considered very typical. If your engine is going from that nice clean to the nasty looking oil in, let's say, 5 hours, then you've got a very valid reason to investigate.
And then we have one, I'm sorry.
Go ahead.
We have one other question. Corrosion is the big problem, but how can I determine if there is internal corrosion? For example, if I'm considering the purchase of an airplane.
Internal corrosion, we'll get to that. One of the pieces of the puzzle is going to be Borescope. The second piece of the puzzle would be if the current owner of the aircraft is doing consistent oil analysis, the corrosion levels will show up with the wear metals.
So, Shawn, I have a question on that. When you say oil analysis, so when I change the oil in my plane, I always, cut the filter and look at the screen inside and stuff. But where would I send my oil off to be analyzed?
Okay. There are a couple of good aviation oil analysis services, and we'll go through it in the presentation, but I'll answer it now. Blackstone Labs is a very good example. They have a little test kit. And when you are conducting your oil change and you're starting to drain off the oil, let about the first quart of oil drain out. And once you've got a good stable flow that doesn't have any contaminants around the drain plug, after usually about a quart, you put the little sample cup into it. You let the airplane pee into the cup and get the amount that you need for the sample. Box it up and you ship it to the lab, and then usually within a week or so you'll get a written report back, which will lay out based off of the engine, the oil that you use, any supplements or additives, what the oil interval changes, and all the other information that they ask you on the lab sheet. Will give you a good indication, and then they give you ranges of what the acceptable levels would be for that particular engine. It's not an exact science, but it gives you a good range. Every engine is going to be a little bit different. And that's how they identify your wear trends. And it will tell you that if you're seeing high numbers in these particular areas, it will be corrosion related. Does that answer the question?
It does. Thank you.
Mm-hmm. Okay. All right. We ready to go for the next section here on Borescope?
Looks good.
All right. Here we go. All right. So Borescopes are fun. If you're kind of a techie person like me, I enjoy borescoping, but also at the same time, if you run out and buy one of these more really good, inexpensive borescope equipment, and you go, ooh, I'm going to go look at my engine. Take a deep breath before you do it, because it will look scary to you to the untrained eye. Right? So don't lose confidence in your engine if you just go and buy the borescope and put it in there. It's going to look ugly. Okay, so borescope inspections are extremely valuable tool for establishing trends and for troubleshooting purposes. Here's a typical example of what's available out there today. The technology has rapidly advanced. You're looking at a couple $100 investment to where 10 years ago this capability would have been $4,000 to $5,000. Kind of put it in perspective. Pretty much anybody who's actively doing engine work is going to have one of these or multiple ones of these. Here's a couple of graphics. Borescope inspection should be accomplished at regular intervals. What's a regular interval? Oh, I don't know. When you change your oil. When you do an annual inspection. Depends on how many hours you're putting on the airplane, right? If you're a typical general aviation flying machine, you're looking at probably less than 100 hours a year. You're going to borescope it annual. If you're running more of a commercial operation and you're putting 500 to 700 hours a year on the airplane, you're probably looking at doing these at the 100-hour inspection interval or whatever your maintenance program is set up for that roughly coincides with 100 hours or every other oil change. All right, so Borescope inspections. It's really important to know what normal looks like. You may go into an engine and it might be absolutely pristine. You go into another engine and there's deposits everywhere. They're both airworthy. It's just knowing what normal looks like. So the way to establish that is get some training on it and go in your engine, take a look around, take pictures of it, get some insight from more of your technical sources that can give you a good indication of what's going on with your particular engine. The graphic here on the left is a cylinder bore, right? You can see that the hash marks are there from manufacturing, which should be there, and that's good, but also notice that there's a lot of corrosion. This particular cylinder is on an airplane that is based near the ocean, and it doesn't fly a lot. So it has a kind of a triple whammy of problems with it's not flown very often, it lives in a corrosion susceptible environment, and with how the aircraft is operated, it's operated on the shoreline at low altitude. So it's picking up salt corrosion all the time, right? So that engine is not going to make it to TBO simply because of its operating environment. All right, picture on the right, see where it's highlighted with the red circle. That is a crack in the cylinder, right? Borescope, you can see the crack, plain as day, pretty much to the trained eye. That crack is not detectable visually on the outside of the engine. Okay? Kind of gives you a reference point. These are deposits, which are harmless on getting close to the valve seat. All right, if the valve had been installed, you'd also see a little bit of deposits, right, with a break point. All right, it's important when you do borescopes to take good pictures and make sure you label the pictures appropriately so that next time you take pictures of cylinder number 1, next time when you go in and look the second time, make sure you're looking at the correct pictures for cylinder number 1 as an example. Keep good records, keep good photos, and don't get in a hurry with it. Just go in, take a good look around, take pictures, and then compare it to what it looked like in the last inspection. Okay. All right, burnt exhaust valves have long been a leading cause of cylinder failures and loss of power. Valves that fail to seat properly are subject to severe and uneven heating, right? They will fail at a very predictable rate. We'll go through that a little bit more here. All right, so you're looking at 3 exhaust valves. Remember, if you're borescoping, the exhaust valve is always the smaller diameter of the 2. Intake valves are always larger. Exhaust valves are always smaller. In all 3 of these pictures, right, you may say, oh, they look nasty. Well, maybe, but every single one of those are exactly fine. They're airworthy, and they have nothing that's trending at this point to be a problem. What you're looking for when you borescope an exhaust valve is you're looking for this nice, even, circular pattern. Okay? Don't be alarmed by the orange or what looks to be a dark brown color. That's completely normal in service. Right? The key here is the symmetrical pattern. Okay? This has got a symmetrical pattern on it, but it looks like a burnt pizza. Okay? The burnt pizza look is the fact that this particular cylinder is running a overly rich mixture. Okay, and you're getting a lead deposit on it. So that's what it looks like. For those of you who are running lean a peak, It's really important for you to make sure that when you're running lean to peak to be very diligent with your engine monitor. And also at top of descent, it's a good recommendation to go rich at peak because your engine exhaust is actually a little bit lower than what the engine was designed to have, and running 100 low lead, some of the deposits from the lead will actually stick to the back side of the exhaust valve, running at that cooler temperature on shutdown. So if you go rich at peak, your exhaust will actually temperature will go up a little bit, burn off that deposit that's accumulated while you were lean at peak and cruise for a few hours, and will prevent excessive exhaust valve guide wear. So just kind of a tip from those of us who look at a lot of engines. All right, so the indications of something going on with an exhaust valve that will at some point need attention is that you do not have a good circular color pattern, right, on the exhaust valve. So that's a trend right there that says we need to keep watching this. Okay? As it progresses in service, this could be, let's say 50 hours, right? Could be 200 hours, depends on the rate that the problem is progressing at, right? Notice that you're starting to get a crescent discoloration and you don't have a circular pattern, right? So this means that you've got a problem with how the exhaust valve is feeding, and you've got what's called a hot spot. That's the hot spot right there. Right? As it progresses, you're going to have more of a burn pattern as it migrates inward. And when you get into severe cases like this, whenever you see green, green in exhaust valves means red. Stop. If you see green on an exhaust valve, it's done. Okay? This valve needs to be replaced right now. When you get to this, from this point here to the point at the end here where you have a crack, right? You're within 50 hours. When you start seeing this indication here, you are definitely within 50 hours of a valve coming apart while the engine is running. And that is a very bad day. So whenever you see green on a borescope, it's time to stop, troubleshoot. This can be rectified by pulling the cylinder and having cylinder work done, or replacing the cylinder. Sometimes the economics work to just replace the cylinder, but that will prevent you from visiting the state troopers on a highway in some cases. So kind of keep that in mind. All right, so quick review. All right, there's many visual trend indicators that are both external and internal. Right? Trending of any kind does require the discipline to amass consistent data. Right? Get in the habit of tracking and trending your information. Right? Save the contents of your oil filters. Take pictures. Right? Look at your filter media. Save the filter media. Right? Really basic, but track down and find the source of the external oil leaks. Right? Some of them you may track down and find the source and say, yep, that's normal, no big deal. Right? We'll keep monitoring it. Others, right? You find that external oil leak and you'll find that there's another problem that needs rectifying. Right? Don't just take the words of the trusted mechanic that says, well, it's a Continental. It's supposed to leak oil. Well, find out why. Right? You're in the seat. You're the PIC. Make sure the airplane's good. All right? Intake and exhaust valves are other areas that are accessible by Borescope. And Borescoping now is quite simple. You're going to pull the plugs and you're going to clean the plugs anyways. The cylinder is open. Put the endoscope down. Take a good look at it. All right? Airplane won't mind. All right. Monitor the oil for sudden changes in color and smell. That's a really big one. especially if you fly the airplane all the time. You're gonna have a little bit better relationship with that engine. So make sure you're watching that. If you go out to an airplane and it's consistently sitting at black oil, and you've got access to the maintenance records and it says that it was changed 10 hours ago, you need to have some considerations with your maintenance chief. All right. No changes in the amount of time it takes for the oil to turn colors. Talked about that. Don't throw away the data. Okay, oil trend analysis. Go through this. Oil analysis has been around since pretty much World War II. It's been considered in the commercial business a standard in turbines, in the airline industry, in the military since the 1950s. If you came out of the military, you know it as soap samples. All right. Can predict service values, normal ranges for wear. Right. Knowing what the component source is of the metal can definitely aid in troubleshooting, and that's what the labs know what metal is used in the engine and can tell you where the wear metal is coming from. It's not some new science. It's been around for a long time, and both Lycoming recommend it. If you want to refer to Lycoming Service Letter L171 or the Continental Standard Practice Manual, the M-0 manual for Continental engines, it will both stipulate that they recommend consistent oil samples. If you're on warranty work, you're going to be on soap samples. All right, so what it does is it monitors the very small amounts of metal that get past your filter, all right, and are circulating through the engine via the oil. All right, it's measured in parts per million, and that's why it's important when you do your oil change to let the first quart or so oil run free, and then grab your samples so that you get mainstream oil. All right. Analysis, you can start oil analysis at any point on an engine's lifespan. It is highly recommended if you're just starting out in an engine overhaul situation to start with the very beginning after the first break-in oil change. But your first sample, whatever it is in the life cycle of the engine, is going to be your baseline, and then regular oil sampling reports done consistently over time is what's going to establish the trend. So when you get your very first oil sample report back and it says corrosion and wear, don't panic. You need to keep flying the airplane and get the next 2 or 3 and see if you have a rate of change. All engines are going to have wear metals. It's just a matter of you're looking to see if they're going up at a high level, if they're level, or in some cases they may be going down. A lot of times you'll see wear metal levels go down when you start using an oil supplement like CamGuard, for example, or if you use a baseline oil, right? You change the type of oil that you're putting in the engine. Right? These trends help determine if the wear material is deviating from the baseline, which is what we just talked about. All right, so let's talk about the stuff that's found in your oil. All right, and this information comes from Ed Collins. He's the technical director of Aircraft Specialist Lubricants. That's the fancy name for the guy who developed CamGuard. All right, so all these things are sitting around floating in your oil. All right, some you should never have in your engine. Some you're going to have all the time. We'll go through it. All right, so aluminum, you're going to have aluminum in your oil analysis report. All right, typically that's going to be coming from the engine piston skirts, the piston pin plugs, or threading from your crankcase halves. All right, chromium, we'll call it chrome. That comes from chrome-plated piston rings. All right, cylinder barrels that have been chromed, and exhaust valves. So if you have standard steel cylinders and you have chrome, you're looking at your exhaust valves. All right, iron, principal wear element that's going to be found in the engine. All right, steel cylinder walls, lifter faces, cam lobes, gears, crankshafts, and camshaft journals. If you get a piece that's large enough through the filter media, that can be sent to a lab independently and can be identified by the alloy to where specifically it is in the engine, just as a reference. All right, copper. You have a high level of copper. Typical sources of that are going to be bearings, or the more cheaper solution sometimes is a deteriorating oil cooler. All right, so if you see bronze on there, or I'm sorry, copper, it doesn't necessarily mean that you're looking at an overhaul next month, but it's something that you may have to do a little bit more digging with. Copper, the two most common things that I've seen for elevated copper is you've got an oil cooler that's about to go, or the customer has recently changed from Phillips 20W50 to Aeroshell 15W50, and the additives that are in the 15W50 have a tendency to strip off the copper plating that's put on camshafts during manufacturing, and that will elevate your copper count for a few oil changes. All right, lead. Well, aviation fuel still has lead. If you're running an STC or you're running automotive gas and you have lead on your report, it's your bearings. All right, tin, that's going to be the babbitt layer, the outside layer of some of the bearings that are installed in the engine. That's fairly typical, especially on a new engine. All right, nickel. Nickel is going to be from exhaust valve guides, or if you have nickel-based cylinder coatings, you'll see nickel on your report. Potassium, that's going to be from coolant if you have a liquid-cooled engine. If you don't have a liquid-cooled engine and you have potassium, you got a problem. All right, manganese, real simple, that's in grease, and if you've had a lot of maintenance done recently, there might be a small amount of manganese that gets into the oil from when the components were assembled. All right, silver, you're pretty much not going to see that anymore. That's going to be radial engines, or if you've got an old Continental E185 series engine. Boron, all right, that's in coolant. Silicone, silicone, pretty much if you see silicone on your report, you need to go look at your your air filter, because you probably got a leaking seal around your air filter and getting unfiltered air into the engine. Some cases, DC4, which is a grease that you put on the oil filter gasket, can ping on the report if somebody really globbed it on. If an engine just came out of overhaul, you may have a little bit of glass beads, and that'll show up on the report. Oops. My bad. Okay. All right. If you see any of these items on your oil analysis, these are typically found from automotive engines or oil. Magnesium, sodium, calcium, zinc, and barium. So those are typically found within a automotive oil. Oil analysis is by far the best trend indicator for engine health, right? And it's also a really good aid in troubleshooting faulty components that are hard to get to. Okay. Remember that all wear metals end up in the oil. The rate of engine wear determines the useful life of the engine, right? So those rates are really important. right? Oil analysis, between 15 and 20 bucks is the additional charge that you'll run into for the lab report. Get a reputable company. They do a good job. Make sure that you do your oil analysis at consistent intervals with your oil changes, right? You need to have at least 10 hours on your oil for the oil analysis to be worth it, because it has to have the level of metal floating around in the oil for it to work. Make sure that you record any replenishing oil. Let's say you put an extra quart in, between oil changes. Make sure you note how much you put in, what oil, and at what number of hours from the last oil change. It is very important for you to select the one lab and stay with their analysis method and their reporting system. If you switch labs or send one month to one guy and 1 month to the next guy, you don't have an apples to apples comparison. So make sure that you pick one lab, send your samples to the one lab, and only look at the reports from that lab for that engine. Okay. If you see, if you're in a pre-purchase situation and you see that the lab reports are from like 3 different labs and whatnot, that's an area to be suspect of. All right, cylinder compressions. All right, these are required by FAR at annual. All right, I'll go through it kind of quickly. This information is going to be in your logbook. Kind of keep in mind, though, that it's not really a good trending tool. All it is a snapshot in time. So what I look for in compressions is consistency rather than the magic, oh, it must be over a certain number. That's not valid. All right. All right. What you want to do when you have compression checks done is, of course, use properly calibrated equipment and make sure that all the cylinders are within 5 psi. If you've got more than a 10 psi split between cylinders, you need to find out what's going on. It might be something really simple like a piece of trash underneath the valve seat. Real easy to fix. Okay. Air leaking past the rings necessarily is not cause for immediate concern, right? The rings will accumulate deposits. They also rotate. On occasion, the gaps in the rings will align and you'll have a little bit of leak between the combustion chamber and the case. Not that big of a deal per se, right? But air leaking past a valve is immediate cause for investigation. Don't just say, oh, it's a piece of trash, it'll blow itself out. Go find out. You got a Borescope, put it in the hole. Right? Make notes. Don't throw away your data. All right? If nothing else, it's everything with engine health monitoring is about having consistent, objective data. All right? Just remember that a compression check is just a simple snapshot. It's much more important to know what's going on with consistency with the compression checks rather than just a magic number. Right? Low cylinder readings should not be an immediate cause for alarm. I know that Continental assembled big bore 6 cylinders without the rings, and they made full rated power. So the compression ratios or compression checks numbers, the magic 64 number that most A&Ps emphatically spit out is actually a spec from radial engines from World War II that A&P schools keep proliferating. It's an easy test question. All right, consider cylinders to be a line replaceable unit. Cylinders can be serviced individually. Right? You need to make sure that you understand what's going on with that and follow the proper procedures, especially with proper torquing. But line replaceable units like a cylinder, doing a cylinder change in the field is not a big deal. You just need to make sure that you have a good comfort factor with the mechanic and that the mechanic has a good comfort factor with doing the work. Right? All right. Electronic engine monitors. Kind of finish this up here. A lot of airplanes these days have electronic engine monitors, especially the bigger airplanes. The prices have become, relatively speaking, in aviation speak, more reasonable, and it is a good investment for putting some type of an engine monitor on the engine if possible. It really works well because it's another piece of data, right? And in flight, it gives you real-time information with your exhaust temperatures, your cylinder head temperatures, a plethora of good information that can be used. They typically have either a card or they have a download capability to where the manufacturers of these and other services have software that will interpret the information, giving you a much better broad view. You combine an electric engine monitor with oil analysis and borescopes, and you've got a really good picture of how well your engine's doing. Right? Third-party software is available, right? And there are professional analysis services available that will do this for you even. So it's kind of a matter of what are you willing to invest and how much sweat equity do you want to put into it. Oil analysis combined with a good visual inspection does a great job of finding a problem long before you hit the start switch. Okay. There's a picture of what it typically looks like on a chart to figure out what's going on with individual cylinders and an engine as a whole. All right, another good tool in the toolbox. All right, conclusions. All right, how do you know that your engine is going to be healthy? Well, it's pretty simple. Trends your way, right? Trends are a good predictor of engine health, right? Multiple data sources, right? Use the tools in your toolbox. Okay. The level of confidence in determining the engine health state, right, is directly affected by your effort and to some degree some cost, right? How much data are you comfortable with? Do you want to have all the data, or do you want to have small tidbits of data, right? Engine reliability is simply being aware and acting on emerging trends, right? And definitely be watching out for sudden changes in any of the parameters that you're looking at, right? The engine does talk to us. We just have some difficulties sometimes listening. Okay. Oil consumption, duration it takes for the oil to turn black, right? New or worsening oil leaks, those are your prime, easy visual indicators to say, all right, the engine's talking to you. You need to be listening to it and go find out what's going on. Okay. All right. Electronic data analysis and oil analysis, very useful tools. A little bit of additional expense involved there, obviously. But the oil analysis is definitely worth it, particularly if you've got over mid-time on an engine, or if you're at the situation where you're 10, 15 years since major overhaul. It's a really good idea to be on oil analysis. If you're not already, go on it. Get a couple oil analysis reports going during the flying season so that you can get a good trend in baseline. All right, so question today is, are you trending or are you going to trend? Right? Can be very simple, right? Do this with a handwritten ledger sheet. You can do it on a spreadsheet. Do it with literally a camera phone in some cases. Take pictures, right? And invest in taking a good look and, to some degree, being involved in the maintenance of your engine and your airframe. Just kind of make sure you're involved. All right. trend your way to peace of mind. That way you know. All right, I'd like to take a quick minute here and do some recognition. I'd like to thank Gene and Lane for making this opportunity available for me. I enjoy passing along knowledge on engines and what I know on the maintenance side. Just like everybody else, there's always a team that's always helping out. Aircraft Specialties provided a lot of the good information that's available in here. Divco, they're a case overhaul facility also in Tulsa. They provided pictures and technical information with what's going on with the engine cases. CamGuard, good information with oil analysis and what they're finding with current trends in the industry with engine operations. Also Pinnacle Aircraft Engines, a lot of good trend data there. They do a lot of heavy maintenance for commercial piston engine aircraft. So they've got a really good database of failure modes also. All right, with that, I will open it up for questions.
Yeah, Shawn, we have a couple of Thomas Ralph, I think it's Tutine, has two questions. One, he said, any idea on how long an engine can be not run without having corrosion problems? And then as a second question, he wanted to know, is any oil manufacturer wait for high temperature climates like Tucson?
Okay. All right. So how long an engine can sit without having corrosion is really going to be dependent on the environment that it's sitting in. If the airplane, for example, is sitting in Florida, right next to the ocean and whatnot, I can pretty much tell you that it'll have corrosion within 24 hours. If you're sitting in Tucson, for example, or you're out, anywhere as close to, the proverbial aircraft boneyards, you're looking at a much greater period of time. Typically, an engine can sit safely without really having to do anything to it for about a month before you'll have any type of real corrosion issue. In terms of engine oils for super high temperature operations, all of the approved engine oils from the manufacturer are good in those temperature environments. If you're consistently having really high oil temperatures, particularly like flight school operations, Tucson, anywhere out west like that, you're probably looking at a field approval of a second oil cooler to provide some assistance with that. But the oil really, the 245 number is what everybody knows as red line. The oils can last above that, but they can't make the overall hours. So if you're consistently running, let's say 260 on your oil, you're looking at having to do an oil change probably at about 15 hours, rough numbers. Does that help?
Yeah. But I think that covered his questions. He also says, great webinar and thank you.
You're welcome.
Okay. Well, that was very good, Shawn. Thank you very much. I've been doing this for well over 50 years, and I learned some things. So there we go. So we'll very quickly wrap this up here. I think you're seeing my screen now and also seeing my webcam. Okay. In case you didn't know it, Avemco offers a safety rewards program. Attendees at this event or any of my other events, or those who take any safety-related education courses, can receive a percentage off their annual Avemco premium at the time of quote or at the time of renewal. And all you have to do is let them know. There's just one remaining webinar in the Avemco series. Next up, a week from today, at the same time, Shawn will be back with us again for a different presentation on aircraft engines. That one is titled Aircraft Engine Longevity and Reliability. We all want our engines to live long, and we certainly all want them to be reliable. To register for that one, please visit vectorsforsafety.com and use the drop-down menu to see the Pilot Talk section. And there's the website, vectorsforsafety.com. You'll find links to all the videos, including all our recorded webinars that we've done, links to some online courses, and you can sign up for our free Vectors for Safety monthly newsletter on that one. So I'll say thanks to Lane for assisting with us again, and thanks to Shawn for the presentation. I thought that was very informative and excellent. I'm not an engine guy. I don't know a lot about engines, and I think back to some of the things that I used to do, and like flying with oil leaks and saying, oh, that's not too bad. I got away with it. I was lucky, but it doesn't always work that way. So we appreciate it, and we look forward to seeing Shawn in this slot again next week. And thank you all for attending. And please remember, fly like your life depends on it. Bye now.